You guys are welcome. Please drop something in the chat box so that I will know those that are with me. Drop something in the chat box. Let me know those that are with me. Good evening, guys. We are here for CIT303, I think. Okay, you are welcome, Valentina. Valentine, sorry. All right, so I think we can start now. Let me share the material. GST, sorry, CIT303. I shared a file with us on the analysis of the past question. So I think we will be using that file to prepare. There was this file I shared. I want us to use it. Because it's going to help us a lot. We've done the analysis of the questions they usually set on that course, and we've been able to see that under each topic treated in the material, there are some questions they seem to always repeat. So we're going to study some of them tonight, tomorrow, and Sunday. So if you are with me, please, you let me know. Let's see those we have here. If you are with me, let me know. You drop a message in the chat box. Okay, I think we have it here. Okay, I will share my screen now so we can start reading. I want us to use the analysis as a kind of guide to our reading. We use it as a guide to our reading so that we don't just go about reading anything. We read the ones that are important. It's not time to be reading all the jargons. It's time to be focused in our reading, like selective reading. What is very important. So let me start to share my screen now. Let's start the screen sharing. I will start from, and because I know I dropped it, most of you guys will not know how to use it. It's just an analysis of what the trend in question has always been. What the trend in question has always been. That is what the whole thing is all about. That is what it's all about. So let's see now, and then we'll start reading. I believe my screen is visible now, so we can start the reading. But if it's not bold enough, let me zoom it in a bit so that we'll be able to see it. We'll not be doing much of talking, just a focused reading for us to get the understanding of what they want to test us on. Don't forget, this is POP, no longer e-exam. They want to test your understanding. Do you really know this thing? or what do you really know about this thing? That is now the case, not what did we write in the materials about this thing, like it was in e-exam. Now it is no longer what did we write in the material. So not cramming, but understanding. Score high probability in this course based on analysis with all the past questions available, starting from 2020. I think we used 2014 down to 2025. All the past questions, we gathered them together, we've done the analysis, and we were able to come up with this area of concentration. That was why I have to drop it for you guys in the group. It's just 10 pages. It's very obvious, like when you check the questions yourself, you pass questions yourself, you will notice that data communication is a kind of, like, is a must. Mostly question one, they repeat it every semester, sometimes in a twisted way, but still under data communication. It's very important to know the definition of data communication. What is data communication? It's very important to know the components of communication before any communication can take place effectively, especially in the computing world or in the ICT world, the information world. We'll be talking about a message. There must be that message you want to pass before communication can take place. Somebody must have a message that is in his or her mind that he or she wants to pass to an audience. And is going to use a means or a medium to pass that message. The medium is that means through which the message he has in his mind will travel through to get to the people he wants to send the message to. And we have some things we also call protocols. Those are the rules, either the rules guiding the medium or the rules guiding the ethics of the communication. So in other words, we have 5 major components of communication or data communication. You transferring data from one computer to another computer, from one phone to another phone. We have 5 components. Good evening, Oluwabiyi, Temilade, you are welcome. So we have 5 components you should bear in mind. This one is not something you should cram, it's something you should know. That if let's use human communication for example. If I want to speak with my friend that is in Canada, there are so many things that will happen. I will need a phone which will serve as a medium through which I, the sender of the information, the person that want to speak to the other person, I represent the sender. The phone represents the medium. My friend there is the receiver. But we have some rules. Like if I want to dial his number now, I must start with +44. Because I want to call him, he's in UK. I want to call him. So I know that there are some rules, some protocols that must be observed. I must have airtime on my phone, on my line that I want to use to call. Those are rules, those are protocols that must be in place before the medium can work perfectly or before the information can get to the person, the receiver. So the sender, the person sending the information, receiver, the person receiving it, the medium, the means through which the message will travel to the receiver. Then the message itself, which is the data or the information you are trying to pass to the receiver. 5 components. So you must understand each of them, their position and their usefulness and purpose in data communication. Very important. So if you have read all about data communication, like the definition, the components, then the characters of communication, the characters of or characteristics of data communication. We have the delivery, the accuracy, timeliness, and jitter. We've studied this in one of the classes we've had before now. So it's not something we should dwell much on. So it's very important if you know all of this. In summary, they ask me tomorrow, define data communication. Write short note on the following: message, sender, receiver, medium, protocol. List and explain 4 characteristics of data communication. I should be able to answer them. So that will take us to going to learn the definition of data communication, 1. Going to learn the components and their position, so that when they say and explain 5 components of data communication, I will be able to write short message, maybe definitions or so write up on each of them. It's not enough for you to know message, sender, receiver, medium, protocol. It's much more enough for you to know what they mean, so that when they say list and explain, you'll be able to ask small explanation that, okay, message is the main content that want to be transferred from the sender to the receiver. Full stop. You have done justice to the explanation of message. The sender is the person with the data or with the information that needs or needed to be passed to the receiver. That is the sender. You've explained. The receiver is the person to whom the message is addressed. You've passed the message. You've explained already. The medium is the channel through which the information or the data will travel through from the sender to the receiver. You explain medium. Protocols are a set of rules that must be obeyed by communication in order for it to be effective and properly, transmitted. You've explained protocol. So if you know small explanation on each of them like this, you have done justice to them, and that makes it you've gotten your full mark. Don't forget, question 1 is always important and is always carrying the highest mark. And mostly in this course, if you go and check the trend, it's always in question 1, data communication. So the evidence is that this same question, data communication, was repeated in 2017, 2018, 2024, 2025. Like directly, they did not change it. So we should be prepared. And the things we should expect is they will ask you to list and explain, like components now. List and explain, like I've mentioned earlier. Characters, they may say you should list and explain. Then define or discuss the component. Don't forget the component we have. We have the accuracy, the delivery, the timeliness, and the jitter, 4 of them. While it has 4 characteristics, it has 5 components. The components are 5, the characters are 4. Components, we have the sender or the message itself, the sender, the medium, the receiver, and the protocol. The characters, we have delivery, accuracy, timeliness, and jitter. If you are still with me, you can kindly type in the chat box the 5 components of data communication. The 5 components of data communication. Kindly type them in the chat box. The 5 components of data communication, if you are still here with me. So let me see those who are still here with me. The 5 components we have, you can type it there, and so that you will be able to recall what we are talking about. Now, we can go to the material and do justice. The next one that normally come out is network topology, but we will not rush. Let's go and do justice to data communication from the material. You understand? Before we now start going to any other thing, let us read from the material and understand and digest it and know how to tackle questions on it before we will now go to any other thing. So tonight, we'll do justice to that part of data communication. And I believe that that question will still come out in this our set. So please don't joke with it. Don't joke with it. Try to know all the components. Try to know all the components and try to know all the characters. The characters, we have the accuracy. It's under characters that we have accuracy. We have jitter as the last one, and so on and so forth. So I think module 1, unit 1 is where they talk about data transmission. And there is where we talk about data communication. So guys, let's go to reading. I'll start sharing my course material now so that we can do justice to reading. we can start the reading and get it all together. So our concern now is to understand data communication. When you are asked in exam, define data communication. You shouldn't be cracking your brain. You shouldn't be trying to remember what is in the material. You should have known it. As an IT person, normally you should know what data communication means. That is the beauty of POP exam. Even what you know, if you write it down, you are on point. It's not by force you go to what is in the material. If what you know about this thing is truly valid and can be compared to the material and you still make sense. Thank you. Awal Ibrahim is still here and you are giving us the right thing. Valentine is still here and the rest of us. Thank you. So data communications, guys, let's get the definition together now and try to come up with what we can write in exam. We are going to read their own definition here. Then we'll come up with what we can write. When they say define, let's see the key things that are important from their own definition. Then we'll now put it in our own definition. So when I'm asked in exam, I will not necessarily need to write verbatim what is in the material. I'll be able to employ the key points that were mentioned in their own definition into my own understanding, then defining it in my own way. Now, what is data communication according to the material? Data communications is the exchange of data between two devices via some form of transmission medium, such as wire cable, full stop. So, from this picture painted here, we can be able to deduce that for communication or data communication to take place, we need two devices. Very important thing to bear in mind is, in the real sense, even in normal communication, let's remove data from it. In normal communication, what is happening now? If you are not there to receive what I am saying, then I'm just soliloquizing. I'm not communicating. I'm just talking to myself. But because there is a receiver somewhere, we have at least two people that want to exchange ideas. That is why communication is possible. So the first point to note there is we have an exchange. And before an exchange can happen, we must have at least two things that are connecting together, two things that are sharing things together. So data communication is a form of exchange of data between devices. So if you are asked in the exam, define data communication, and you are able to remember that data communication is an exchange of data between devices. You don't need to start writing two devices via some transmission. Well, adding transmission medium is very important, because when you say it's an exchange of data between devices, how did it happen? It happens through a medium. Don't forget, we said we have component of data communication where we have the message itself, the sender, the receiver, the medium, and of course the protocol. All of those things that are components, you are meant to put them in your definition so that your definition will be full, will be complete. So here they say through some medium. Example of medium, we have wire cable. For data communication to occur, the communicating devices must be part of a communication system made up of combination of hardware, which is the physical equipment. Of course, we know what hardware means, and software programs. The effectiveness of a data communication of a data communication system depends on four fundamental characters. It depends on delivery, accuracy, timeliness, and jitter. That is what takes us to the characters of data communication. Don't forget, in this summary I dropped for you guys, exam focus I dropped for you guys, it has been simplified. All you first need to know is the meaning of data communication, which is an exchange of data between devices using some transmitting medium, full stop. If you have written that, you have your A already in that explanation or in that definition. Now, if you are asked about the component of data communication, what are the things that must be in place for data communication to be possible? We have the message that want to be transmitted, or the data. The data must be there, which is the message. The sender must be there, the medium must be available, the receiver must be available, and also we have the protocols, which are rules that must be obeyed. All those must be put in place for data communication to take place. Then we have characters of data communication, which we have accuracy, timeliness, and delivery, and of course jitter. Now, what's the if you are asked to write short notes or list and explain the four characters or characteristics of data communication, what explanation will you give? Let's see what each of them means. What does delivery mean? What does accuracy mean? What does timeliness mean? And what does jitter means? Delivery under characters of data communication, it means that the system must deliver data to the correct destination. Data must be received by the intended device or user and only by that device or user. So, delivery as a character of data communication means if I turn on my Bluetooth now on my phone and I turn on my Bluetooth on my PC and I want to send the data from my PC to my phone, when I connect the two of them, when I send the data, it will not be my brother's phone that is staying downstairs or somewhere else that the data will enter. It should be delivered to the same device I have connected together through some protocols. That's what they are talking about on delivery. So delivery means the message, or sorry, the data must be delivered to the correct destination. It's as simple as that. You don't need to write long grammars, big grammars. The delivery under the characters of data communication means that the data must be delivered to the correct destination. Then what of accuracy? The system must deliver the data accurately. Data that have been altered in transmission and left uncorrected are unusable. For instance, when you are sending a video from your PC to your phone through Bluetooth, then all of a sudden your phone went off while the thing is just in 70, let's say 70% or 72% or so. By the time you turn on your phone after charging it, you find out that the file will be corrupt. Why is the file corrupt? It is no longer accurate. What you sent from the PC is actually accurate, but something went wrong during transmission which made it fail to transmit completely. Then the file becomes corrupt. That is the issue of accuracy. It's no longer accurate. So that is the understanding of accuracy under the characters of data communication. Now, timeliness. The system must deliver data in a timely manner. Data delivered late are useless. In the case of video and audio, timely delivery means delivering data as they are produced in the same order that they are produced and without significant delay. This kind of delivery is called real-time transmission, like what we are doing now. If what I am doing now, it is after 2 minutes, you are able to hear what I'm saying currently. Something is wrong in the transmission. It is not timely. And this is a real-time program. Online, you are watching it live. So you are streaming it, it must be real-time. What I'm sending here, you must be seeing it or hearing it instantly. So if it's delaying before it gets to you, you are seeing it like 3-4 minutes backward, something is wrong. That is timeliness issue. So data must be sent or must be delivered in the correct time manner. That is timeliness. Then of course jitter refers to retaining the quality. Like jitter refers to the variation in the packet arrival time. It is uneven delay in the delivery of audio or video packet. For example, let's assume the video packet are sent every 30 minutes. If some of the packet arrive with 30 minutes delay and others with 40 minutes delay, and uneven quality in the video is the result. What I'm trying to say is, let's use this YouTube for example. If I'm actually saying we are doing this video now and it's not delivering late, it's likely it's going to be blurred when you are seeing it, or the quality will not be bright enough, you'll not be able to see it clearly due to the delay. So jitter means the variation in the packet arrival time, the differences in the packet arrival time. Now you do something for yourself so that you'll be able to retain what we have just done. Kindly define data communication in the chat box. What is data communication? In your own words. You don't need to cram or use the exact thing we have just finished reading. What is data communication in your own words? Answer it there in the chat box. Secondly, you are going to write short notes on each of the characters of data communication that we have, the delivery, accuracy, timeliness, and jitter. Write short notes on them. That is a short classwork. That is a short classwork. So let's quickly find a way to do that before we go to component. Of course, we've briefly talked about component too. Like the component, we have the message, the sender, the receiver, the medium, and the protocol. I think the one that we may not be familiar with is protocol. We know already who a sender is, the person sending the information. We know who a receiver is, the person sending the data or the message, or the computer sending the, the message, the receiver, the computer receiving the data or the message, while the medium is, the means of sending. But what of protocol? Let's read a bit about, okay, let's not believe that everybody already know message, sender, receiver. Let's see. I'm not seeing you guys typing anything. I've dropped a classwork for you. What is data communication? And then list and explain shortly the the 4 characters of data communication that we have. That is the accuracy, the timeliness, the jitter, and what other things we mention under the characters of data communication. It must be accurate, it must be timely, then the jitter, and one other thing there, which is delivery. That is one I should not even forget. Delivery. So under, yes, Awar Ibrahim is saying data communication is the process of exchanging communication between between people or whatever via a transmission medium, e.g. wire cable. You are giving them verbatim. Don't learn to write verbatim. It's not safe. That if you have been checking the what is it called, malpractice list over time, you find out that POP, they say the person wrote exactly how it is in the material. So in their own opinion, you went into the exam hall with the material to cheat. So please learn to use it in your own words. Now, message under the component. What are the things that must be in place for communication to take place? We are not talking of characters now. The characters, we have delivery, timeliness, accuracy, and jitter. Now we are going to component, the things that must be in place for data communication to take place. We have message. The message is the information or data to be communicated. Popular forms of information include text, numbers, pictures, audio, and video. For instance, when they say you should give example of message or messages, we have text, we have numbers, we have pictures, audios, and so on. Anything that is a form of data can be a message. Just like you are chatting on WhatsApp, you are messaging yourself. That is the message. If you know the message you can send to each other on WhatsApp can be text, it can be audio, it can even be video recording or anything. So the sender is another component to take place. Okay, Valentine says data among the computer. Okay, among the group of computer using a transmission medium. Thank you. That's okay. They just need to know that you know what they are saying, not writing what is the material exactly. Now, sender. The sender is the device that sends the data message. It can be a computer, workstation, telephone, handset, video camera, and so on. Receiver. The receiver is the device that receives the message. It can be a computer too, workstation, telephone, handset, and so on. So we have the transmission medium. The transmission medium is the path by which a message travels from sender to receiver. Some examples of transmission medium include twisted pair wire, coaxial cable, fiber optic cable, and radio waves. When we have protocol, it's even that protocol I want us to learn, because I know every other ones that I've mentioned, message, sender, receiver, transmission medium, you may have idea of those ones. But what of protocol? What is protocol in component of communication or data communication? A protocol is a set of rules that govern data communication. Set of rules that govern communication. That's all you need to pick out there. Protocols are that must be obeyed for communication to be successful. That's another way you can put it. When you are asked in exam, Write short note on the following. Protocol under the component of data communication. Protocol under the component of data communication can be defined as the set of rules or rules that must be obeyed by the communication process for it to be successful. It sends an agreement between the communicating devices. Without a protocol, devices may be connected but not communicating, just as a person speaking French cannot be understood by a person who speaks only Japanese. That is absolutely correct. That is absolutely correct. Then we can talk about the type of data we have, like the text, the audio, the video. You see, this course is supposed to be sweet, and I believe it's going to be sweet for us in exam, because those are things we are generally used to on daily basis. There are things you know, you appreciate, things you are working with every day. You press your phone every day. You are communicating on your phone every day in one way or the other. So what is happening is data is being transmitted. All of those things you communicate, those chats, laughing, communicating with your friends on phone and the rest, all you are just doing, you are transmitting data between yourselves. And what is happening there is what we call data communication. So when you are asked a question under data communication, just remember your day-to-day chatting with your friends and family and try to study it. What is happening when I'm chatting with Awa? I from my own device. Let's say I'm using a Samsung device. I say, or from my laptop, I said, "Hi, Awa." The message left my own side. I saw it tick and show sent. Awa opens her own phone, which is the receiver now. She saw the message. When she opened it, I saw double tick on my own end here to show that Awa has received the message. You understand? So when Awa received the message, why is it that Awa did not receive hello Awa when I sent hi Awa? The reason why the message delivered accurately, you understand, and timely, because if I send it on WhatsApp at 12:05, it will land on our own phone at 12:05. There may be the only reason why there will be delay before she will be able to access it is if her data is not on. What is the purpose of data there? Is serving like a form of protocol, a rule rather, set of rules. The rule says that if I have data on my own phone and I send an information to Awa, but Awa is not having data on her own phone, the fact that Awa is not having data on her own phone means Awa will not be able to receive the message on time. The message has dropped on her own phone, but because her phone is not obeying a rule, which is a rule of data must be on and data must be available on the line, on the network carrier that you are using to access the internet before you be able to see messages on WhatsApp. So if our phone is not obeying that rule, which is protocol, then something will be wrong. The message would have delivered from my own end. It has gone from my own end as a sender. The medium has carried it. It has been delivered, which is delivery. But the issue of timeliness, we have fault there, because until Awa is able to obey protocols, which is buying data on her line and turning on her data before she will see the message. That is the logic. So what type of data do we send? You can also use your day-to-day activities on WhatsApp, on Instagram, or anywhere you chat to understand this topic. What kind of data do you send? Mostly on daily basis, we send text. Hello, hi, this is an announcement. We are going to have this by so time tonight. All those texts we type, they are all data. Voice note, which is audio. Sometimes when what you want to say is very emotional, or you want to put in some kind of action into it, you feel to use voice note rather than text. Or sometimes maybe your hands are tired, you're so busy, you just prefer to use voice note. Voice audio is also data. You can use video. You can record something in video to show some people, do it yourself. This is how to do this thing. You record it, you throw it to them as a video, they watch it. That is communication, that is data. So data is not only text, it can be in video, can be in audio, and so on and so forth. All you just need to know is that the type of data format or forms we have the text, the numbers, And of course, numbers is all about the digits that we have, 0 to 9 and so on. Text can from A to Z, and then their manipulation of A to Z is what will give us text. So anything I'm writing is between A to Z. Manipulation of 0 to 9 will give us numbers. No matter the number I type is between 0 and 9. Then we have images. On daily basis, you send pictures to your friend, you take shots, you say, oh, how do I look? So you can send images to yourself. It's also a form of data. We are just talking of types of data you can communicate between systems, between communicating devices. We have images, we have audio, like I've mentioned earlier, we have video, So we'll move to something we call data flow. But before we talk about data flow, I would like to go back to, so I believe now let's do a very short, thank you, you guys are really doing well. At least you are typing something there and I can see that you are with me. But I need us to do something very simply. And that is on what we've just finished doing now. I have just finished showing us the types of data we have. Kindly drop any four types of data you know. Any four types of data you know. Drop it in the chat box. Any four types of data you know. You don't need to explain them. Just tell us any four. List four data types that you know. Then we'll go to this material back. This is our analysis. So I think if data communication should come out now, I know what to write because I now understand it, not just reading alone. I know what it means. I know that even my day-to-day chatting with my friend is data communication. So I can use that one alone to answer that question. The idea that I have from my day-to-day chatting with my friend, sending files to my friend, sending summary to my friends in the group, dropping files, dropping messages, voice note. I am doing exchange of data, and that is data communication. That will help me. It will create a very clear picture in the exam when I see the question, so I'll be able to answer it effectively. Now, then the components, the characters, and the types of data we have done justice to that. The next thing that is very important for us to learn is network topology. And I don't think we'll go into this tonight. I don't want a situation where we dive too fast, but we can just touch it a bit. I think we still have time. I will release us by 1 or 1:15. I will release us by 1 or 1:15. So let's go to network topology and read about it. One thing you should know is that computer networking is the interconnection of computers together for communication or for data transfer or data communication. When you connect one computer to another, the process of connecting them together is what we call networking. So that is what we call networking. You are connecting computers together. You connect this computer to this computer, and of course, we are going to have a network. So there are so many forms, arrangements, appearances of network types. That is what we call topology. The appearance, the arrangement, the form, the formation you use in connecting those systems together so that they can communicate to each other, so that system A can send data to system C and system C can transfer it back to system B. System B can. So for that kind of communication to happen, like in the office space, like in a company setting, or even your house, maybe you have several computers. Daddy's room is having computer, mommy's room is having computer, your brother's room is having computer, you yourself, you have a computer in your room. Each of you want to be sending communication remotely in the house without having to remove memory card or flash from one system to another. You can create a very small system network there in the house. But there are so many ways of connecting your computers. That is where we have the topologies of system connection. And network topologies, we have the type of the bus, the ring, the star, the mesh. Basically, we have four: the ring topology, the bus topology, the star topology, the mesh topology. Why their names, they look, the arrangement is somewhat similar to the name. In the real sense, it's not like that, because if you want to draw it now, you will see that the star topology is looking like star. the arrangement is looking like the normal star, the bus topology too, you see the ring is looking like a ring. But let's see what we can do on network topology tonight. Maybe we'll just get their definition, study some diagrams, and then this network topology, they like asking it. You can see evidence of this network topology. If you go and download the past questions yourself, you will see evidence of it from 2014, 2017, 2023, 2024, 2025. They repeated topology consecutively. So let's see. Let's go back to the course material and read about network topology and their designs, how they look like, their types, few definitions, and then we are all done. Okay, where do we have this? Under this topology, we'll be talking about layers and the rest of them. We'll still study about OSI and the rest of them, all those layers, but not tonight. Maybe on Saturday class or Sunday for our final preparation. So module 4 was the one that talked about computer networking. And the unit 1 talks about networking models, while unit 2 is what we are concerned about, which is network topology. Unit 2 is network topology. Yes, I can see Awa Ibrahim and Oluwabiyi and Valentine. You guys have dropped the type of data we have. Thank you. That is correct. So let's see. Let's go to unit 2, where we want to talk about network topology. We have the method. We'll read that too, but let's do topology tonight. We move to good. Now we are there. Network topology, which is unit 2 of module. What is that? I think module 3 or okay, module 1. So what's the first thing you need to know about topology? Do we have definition? The network topology defines the way in which computers, printers, and other devices are connected physically and logically. A network topology describes the layout of the wire and devices as well as the parts used by data transmission. Just a design, a kind of link between system A to system B to the printer to the router and everything you are using in the house or in the office. The way they are connected together logically is what we call topology, the network topology. First of all, the interconnection together is a network, but the arrangement you use is a topology. Let's get the two together. We have network, we have topology. In that compound word, network topology, two things are involved. The first one is the network. The network is the connection you have, the interconnection of those computers together or those devices. Let's not use computer alone, because in network topology, you have the printer, the computer, the router, anything you are connecting together on that network. So networking is the interconnection of those computers together. Or sorry, let's use devices, not computers alone. Interconnection of those devices together in order to share data. The purpose of networking is for those devices that are participating in the network to share data and information. So that is networking on its own. But topology is the method, the layout, the arrangement you use, where this device stays, where the printer stays, where. So we have several topologies. That is what we want to see. So that when you enter office, you go to maybe this company's office arrangement and you see the way they arrange their whole thing, and you go to this other office and they are using the same set of devices, but this office is having another arrangement. That is what we call topology. This office may adopt ring topology. This office may adopt bus topology. Another office may adopt star topology, while other may adopt mesh topology. It all depends on the style they want to use. So we are going to get the reasons why those things differ when we study topology. Now, network topology has two types. It has the physical and the logical. And commonly used topologies include bus, star. Please don't joke with this network topology. Let's understand it very well. Don't cram it. I've tried to explain it better. The network itself is the interconnection of computers together or devices together to share data, while the topology is the system, the layout, the design you use in arranging them. So network topology is one thing they repeat almost every, in fact, let's say every semester. You see a question under topology. If this semester they ask you drawing under topology, next semester they may just have you definitions of terms under topology. So let's understand them. While it has two types, the network topology we are talking about, it has basically two types. We have the physical and the logical. Then we have the type of topologies we now have, the basic types of topology that are mostly used. Those are the bus, the star, the tree. The tree is one they also call hierarchical in case you are asked in exam. The tree is one called hierarchical, and the linear, the ring, and the mesh. Those are the possible, but the most common ones that are very used in our day to day. We have the bus, the star, the mesh, and the ring. Those are the four common ones. So these three, this linear, they're not that common. Now, we also have the partially connected, the fully connected, sometimes known as the fully redundant. And those are the possible topologies we may have or you are likely to see in offices. Now, the network topologies mentioned above are only a general representation of kinds of topologies used in a computer or used in computer network and are considered basic topologies. Topology in network design. Now let's look at proper understanding of this topology. Think of a topology as a network's virtual shape or structure. From what I've been saying, this is what we can say topology means. The shape or the structure of the arrangement of the network. This shape does not necessarily correspond to the actual physical layout of the devices on the network. For example, the computers on a home, and you know that the home use a local area network, which is LAN, may be arranged in a circle in a family room, but it would be highly unlikely to find a ring topology there. And you know that it is the ring topology that looks like a circle. So what they're just trying to say is that the physical arrangement of devices in a network in most cases does not really mean that that network is using the physical topology that relates to the design or the structure. So if you go to an office and you see that they arrange everything, the devices in a circle, don't quickly conclude that what they use there is ring topology. It may not be ring topology. That's what they're trying to tell you, that the physical arrangement sometimes may not predict or tell you what kind of topology is used. So network topologies are categorized into the following basic types. The basic types we have the bus, the ring, the star, the tree, and the mesh. Don't forget, they all have meaning. When we start talking about them one by one and start looking at their images, the drawing, those of you that will write in school, be ready to draw. Please be ready to draw. So when you see drawings like this, the drawing there are not hard, they are not that tough. It's just for you to draw symbol a box of a computer and then do the arrangement. Now this is a bus network topology. You can see the way it is arranged. All you just need to recall is the arrangement. So when you want to draw it in the exam, you know you first draw a straight line, a vertical line, draw 4 computers or maybe 4 or 5 computers, arrange them like this in order. That is all. You've drawn bus topology if you have drawing. So we may not talk much on bus topology and the rest of them tonight, but I just want you to understand something from this place, like a summary. The definition of network topology. I have broken it down by giving us the meaning of network on its own and topology on its own, and then we're able to come up with an idea that network topology is like the structure, the layout, the design that was used to arrange the network of that computer network or networking. And then we have the types like the bus, the ring, the mesh, the star, and the tree. Don't forget those. types we have too. Once you are able to hold those in your mind, you have some clues to answering the question already. So if they now ask you further that explain or write short note on the types of network topologies that we have, that is when you need to start talking about what is bus topology, what is ring topology. Or when they ask you to draw a particular topology, like for instance, if they ask you draw the star topology, which means we must be able to identify the difference between that drawing. This is the drawing of bus topology. When we go down to the star or the ring, you see this is the ring topology. It looks like a circle. That was why they told us earlier that the fact that the arrangement of an office computer, an office network is looking like a circle does not mean they use a ring network topology. This is the ring. Ring is very simple to draw. Just draw a circle, draw computers on the circle as if they are communicating in circle. That is the ring topology. We have others. You just need to appreciate the designs so that when you are asked in the exam, you know which one to draw. If they ask you to draw star topology, you will not go and draw ring topology. Bus topology is you drawing a vertical line. You can draw two system up, two system down, draw connecting cables, connecting them to the vertical line. So it shows communication. The ring is when all of them are in circle. The star, look at it. It looks like a star. Several computers connected to a server. Several computers, each of them connected directly to the server. When we start reading about each of them one by one, you will understand the way they operate. From this drawing now, we can see that for star topology, each of the device is connected to a central device or a server. For ring topology, if you notice the drawing of ring topology, you see that each computer is connected to each other. Each of them is connected to the other one. That is, in ring topology, the connection is like this. Each computer connected together. In bus topology, we have a carrier. This vertical line is like all those cozier table or cable. This is a cable now where the data is being fed. So each of them is connected to the cable directly. We have a single cable carrying the data around. Each of them is being fed from that. Each of them has its own explanation. When we read about them, you understand. I just want us to know the difference between those diagrams so that if it's star, they ask you to draw an exam, you will know which one is star. If it's ring, they ask you to draw, you will know which one is ring. Don't forget that ring is the one in circle. Star is the one that has a server and every other computer is connected to it. Bus is having a vertical line which represents a data cable and each computer is connected to the data cable. Then we have the tree. The tree is like a multiple connection or a multiple combination of the star. If you look at this tree topology, you can see that it looks like the star combined together more than one star topology. So the combination of star topologies will give us a tree topology, because in this case too of tree topology, you can just draw like 3 star topologies individually, understand, then connect them together. This is how to draw tree topology. You can see if you remove this one alone, this one in the middle alone, we are going to have star topology. This one on this side, if you remove it, we have star topology. Even this one here can stand alone as star topology. However, when they are all connected together, they give us something we call a tree topology. So it can be said to be a combination of star topologies, combination of two or more star topology. Then we have the mesh topology. The mesh topology, how does that one look like? Look at this mesh topology. It's a central server. The mesh topology has a central server. We have some computers directly connected to the server. Let's see this clearly. We have 3 computers connected to the server. Then those computers are also serving other computers. So while they are connected directly to the server, other devices connect to them. So what they are getting from the server, they are serving to the others that connect to them from other ends. That is mesh topology. Some are connected to the server directly, others connect to those that are connected to the server. I don't know if you can use something clearer to explain this mesh topology. For instance, if uh, well, I'm trying to get a very clear picture for us to get understanding. Wi-Fi will not work. Wi-Fi will not work. Wi-Fi will not work because if a device is connected to Wi-Fi, another one cannot connect to that one. No, 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 that is not a good one. And even Bluetooth will not. I'm just trying to get something we are very familiar with that we can use to explain this arrangement. Just know that for mesh, we have some of the devices connected directly to the central server. Then you will now connect other devices to them. That is mesh topology. So far, so good. You have seen the diagrams of the bus topology, a vertical line, computers connected above, connected below to the vertical line. The computers are not connected together directly, but they are all connected to the vertical line. That is bus topology. The ring topology, everything in a circle. So each computer is connected to the other in a circle. The star topology, a central server is there and each computer is connected, or each device, it's not only a computer that we have on the network, each device is connected to the central server. The tree topology, is a combination of two or more star topology. So when you draw a star topology here, you draw another star topology, then you draw another star topology, you now connect them using a line or a cable. So you connect star topology one to using the server. Is the server alone you are going to connect the server of star topology 1 to the server of star topology 2 connected to the server of star topology 3. In that case, you have a tree topology. While on the final note, the mesh topology is a type of topology where we have a central server. Some devices are connected to the central server while other devices connect to them. So that is on mesh. So far, so good. We've talked about the several types of topologies we have. We have the bus, we have the star, we have the ring, we have the tree, and we have the mesh. Don't forget them. Then we'll talk about the main forms of topology we have. It can be physical, it can be logical. Don't forget that one too. The main forms of topology we have. Topology may appear in two forms. It's either in the physical form or in the logical form. And what is network topology on its own? Network topology is the arrangement of networks, of computer networks, or the interconnection of computers on the network to share data. So the structure, the layout, the design used in connecting them together on that network is what we call topology. So network topology is the layout, the design, the structure in which a computer connection or a network connection is created. So that is the idea or logic you need to understand. We are now, this is 1 a.m. and I think in this short time, we have done justice to some important things in this course. If we're able to do it like this tomorrow and then Sunday, I'm sure we have A1. But don't forget, we have 2 courses on Monday. So tomorrow, we'll make sure we finish this one. Everything we want to read on this course, we'll finish it tomorrow. Please, if we'll decide in the group, if we should hold a class in the evening tomorrow and even in the night or twice tomorrow, so that we'll finish all the important topics on this course. Then after this course, we will do the second course on Sunday. We will dedicate Sunday to the second course we are having on Monday. And I believe God will help us. You see, POP is very simple. Just understand. Don't cram. Just understand. Relate it to things that are happening around you. Get them connected. Anything you are reading, connect them to things that are already happening around you that you know, that you understand. And it's going to be very easy. God will help us. Guys, let's go and relax now. We've done justice. This 1 hour is a very vital one. We've learned quite a lot in 1 hour. So thank you for staying to this time. and think it's time to rest for the weekend. Have a wonderful night, guys. See you tomorrow. We'll decide in the group where we are going to hold the class tomorrow. Bye bye.